Good afternoon, sixth graders. It's Mrs. Hebert. I apologize. I think I'm getting laryngitis, but hopefully I'll make it through the lesson. We are starting Module 13, and so we're going to be doing 13.1 today. We're going into geometry, and 13.1 is a lesson about area of quadrilaterals. So go ahead and put that on in your table of contents. I believe the pages are 63 and 64. Okay, when you set up your page, you need to set it up in 4 wide sections. And so at the top, go ahead and put 13.1, area of quadrilaterals. And then box number 1 should be your biggest box, and the other 3 can be about the same size. Okay, so in box number 1, you're going to be writing some definitions and showing some examples. And there are basically 4 terms that you really need to understand in order to figure out area. One is quadrilateral, which a quadrilateral is a 4-sided figure. And so you could have a square, a rectangle, a rhombus, it could be a diamond, it could be a trapezoid. As long as it is a 4-sided figure, it's a quadrilateral. The next one is a parallelogram. A parallelogram is a quadrilateral, so it's a 4-sided figure as well, but it has 2 pairs of parallel sides. And so that means, it could be top and bottom that are parallel, and then left and right are parallel. So they're not all parallel to each other, but opposite of each other, they're parallel. So for example, a parallelogram and a rectangle. Well, the parallelogram, sorry, that's what it is, but it looks like the slanted rectangle. Then a rhombus is a quadrilateral, so it's another 4-sided figure in which all sides are congruent. And remember, congruent means equal. And the opposite sides are parallel. So in this case, and when we see a rhombus, we usually see something that looks like a square that has been squished sideways. That's the most common type of rhombus, but really any quadrilateral where all the sides are congruent and the opposite sides are parallel would qualify as a rhombus, even a square. And then a trapezoid is a quadrilateral with only 1 pair of parallel sides. So unlike the parallelogram that had 2 pairs of parallel sides, the trapezoid only has 1 pair of parallel lines. And a trapezoid, you usually see, like in the first example I have here, is what you would normally see as a trapezoid shape. But the other 2 can also be trapezoids. They don't have to be slanted opposite of each other, exactly the same, to be a trapezoid. Okay, in box number 2, we're going to work on learning how to find the area of a parallelogram. And remember, the area is that space inside of the flat figure. And so for a rectangle, if you recall, the formula for the area of a rectangle, which we've talked about several times, is length times width, which is very similar to the area of a parallelogram, and a rectangle is a parallelogram. But instead of calling it length times width, we now call it base times height. And so the formula for area of a parallelogram will be A equals base B times H, which basically means area equals base times height. And notice that the A is a capital A. That capital A stands for area. So then you can draw the 2 examples. We have a parallelogram that is just a rectangle, or you could draw the parallelogram that you more often see, and then you'll see that I put some dotted lines, and that's because if you look carefully at the second parallelogram, even though it is slanted to the side, you could take off the triangular shape on the left and you could move it over to the right-hand side of the parallelogram. And if you put it there, you would have a rectangular shape. And so that's why the formula is the same as it is, for a rectangle. And so that's just to show you that even though they're different shapes, they can be reshaped into the same shape. So the area is going to be the same. So in this case, the area of this parallelogram is the base times the height, and I know that the base is 5. Whoops, that is going to be way too big. Okay, let me try change that. Sorry about that. Okay, so the base is 5 inches, and the height is 3 inches, and it says it's base times height. So the area is going to equal 15, and this is inches, and because it's area, we have to square it because we're taking into account 2 dimensions. We're taking into account the base and the height. So we square our answer, and our answer is area equals 15 inches squared. In box number 3, we're going to find the area of a trapezoid. And this is probably a formula you haven't seen before. But the formula for the area of a trapezoid is area equals 1/2 times the height times the sum of base 1 plus base 2. So base 1 and base 2 are basically the tops and bottoms of the trapezoid. And they are noted with that little number at the bottom because those are not exponents. They are just labeling the difference between bases. So those numbers go at the bottom. And so if I have a trapezoid that has a height of 16 feet, and then the bases are 20 feet and 39 feet, because the bottom is, in this case, is longer than the top, I'm just going to plug those numbers into my formula, and I'm going to say area equals 1/2 times the height, and my height is 16 feet, so 1/2 times 16, times the sum of base 1, which is 20, plus base 2, which is 39. Then I'm going to use PEMDAS. I'm going to do the parentheses first. So 20 plus 39 is 59. Then I'm going to multiply that, create a new problem, and now I have 1/2 times 16 times 59, and I'm just going to take it and go in order. So 1/2 times 16 is 8, and 8 times 59 will be my new problem. And if I multiply that out, 59 times 8, 9 times 8 is 72, 8 times 5 is 40, plus 7 is 47. So my area is going to be 472. In this case, it's feet, and because it's area, I'm going to square it. So 472 feet squared is the area of my trapezoid. Okay, now I'm going to look at the area of a rhombus. And a rhombus, you know, the traditional looking rhombus would look like a squished square, kind of a square that's been slanted, pushed over at the top. And the formula is 1/2 times the first diagonal times the second diagonal. And those diagonals are those dotted lines that go from corner to corner. And so in this case, I have the D1 represents the first diagonal, and it's 4 feet from one corner to the other. And in the second one, the second diagonal, it's 3 feet. So I plug that formula in, and I say area equals 1/2 times D1, which is 4 feet, times D2, which is 3 feet. And this is all multiplication, so I'm just going to go across 1/2 times 4 is 2, times 3, which equals 6. So my area for this rhombus is 6 square feet, or 6 feet squared. Okay, so when you look at your finished paper, this is kind of what it should look like. I added a little something on the finished paper under rhombus, just in hopes that you could get a better idea. And that is that I said, if you look under rhombus in the pink, it says that any parallelogram with equal sides, including a square, can be a rhombus, basically. Even though we normally see them like the way I've drawn it in the picture, it can be any parallelogram with equal sides. And that's really it for the lesson. We're going to be doing some more work with that, but you basically have to learn the formulas that go with each of these. and you have to know the process of, you have to know PEMDAS to do that. But it helps to understand what each shape is, and we'll talk more about that in class. And that's it. You're done. Good job.